Welcome to a video on solving absolute value equations. In this video, we'll look at how to solve absolute value equations both algebraically and graphically using the free online calculator Desmos. Let's get started. Let's start with reviewing a few important concepts about absolute value. For any real number a, the absolute value of a describes the distance from 0. For example, the absolute value of 4 is 4, and the absolute value of negative 4 is 4. And this is because if you look at the number line, the number 4 is 4 units away from 0, and the number negative 4 is also 4 units away from 0. Since the absolute value describes the distance, the absolute value of a number will always be 0 or positive. This also means that the absolute value of a number will never be negative. And this is an important point that will come up again when we look at solving absolute value equations. So we will revisit this again. Now let's take a look at the different types of solutions for absolute value equations. For any real number c, an algebraic expression a, the equation, the absolute value of a is equal to c, will have the following types of solutions. If c is greater than 0, in other words, if c is positive, then the equation, the absolute value of the algebraic expression a equals c, has two solutions. The algebraic expression a equals c, or the algebraic expression a equals negative c. If c equals 0, then the equation, the absolute value of a equals 0, has one solution. You'd set that algebraic expression equal to 0. If c is less than 0, in other words, if c is negative, then the equation, the absolute value of the algebraic expression a equals c, has no solution. And this goes back to what we previously mentioned, that the absolute value is always positive and it will never be negative. For example, if you wanted to solve the equation where the absolute value of the quantity 4x minus 3 equals negative 2, this equation has no solution. And this is because the left-hand side of the equation is completely contained in that absolute value. So that means no matter what x is, the value of the left side is going to be a positive quantity. And a positive quantity can never be equal to negative 2. So this equation has no solution. Now let's take a look at the steps to solving absolute value equations. As we look at the steps, we'll solve the equation 2 times the absolute value of the quantity x plus 1 plus 3 is equal to 17. The first thing that we need to do is to isolate the absolute value of the expression. So we want to get this equation into the form where we have the absolute value of some algebraic expression a equals c, where c is just some real number. Looking back at our equation, we want to get the quantity, the absolute value of x plus 1 by itself. So let's go ahead and subtract 3 to both sides. This would leave us with 2 times the absolute value of the quantity x plus 1 is equal to 14. Now we need to divide both sides by 2. This leaves us with the absolute value of the quantity x plus 1 is equal to 7. Now we've isolated the absolute value to one side of the equation. The second step is to check the value of c. If c is less than 0, the equation would have no solution. If c equals 0, then the equation only has one solution, where the algebraic expression equals 0. And if c is greater than 0, the equation has two solutions. Looking back at our equation, the value of c is 7, which is positive. That tells us that this equation is going to have two solutions. The third step is to rewrite the absolute value equation as two equations. This is where the algebraic expression inside the absolute value, a, is equal to c, or where a is equal to negative c. So looking back at our problem, we would take that algebraic expression inside the absolute value x plus 1, and we would set x plus 1 equal to 7, or x plus 1 is equal to negative 7. So essentially, this is saying that a equals c, or a equals negative c. Now we need to solve the resulting equations. Let's solve the first one. To get x by itself, we'll need to subtract 1 to both sides. So we end up with x is equal to 6. Now let's solve the second equation. Once again, we need to subtract 1 to both sides. So we get x is equal to -8. The last step would be to check our work. Let's go ahead and check that x equals 6 is a solution to the original equation by plugging this in. So this would give us 2 times the absolute value of the quantity 6 plus 1 plus 3, and we want to know, is that equal to 17? This simplifies to 2 times the absolute value of 7 plus 3. Is that equal to 17? Well, the absolute value of 7 is just 7. Multiply that by 2, this would give us 14 plus 3, which is definitely equal to 17. So x equals 6 is a solution to our equation. Now let's go ahead and check x equals -8. Plugging this into our original equation, we would have 2 times the absolute value of the quantity -8 plus 1 plus 3. Is that equal to 17? Simplifying the inside of the absolute value, we would have 2 times the absolute value of -7 plus 3 is equal to 17. Now the absolute value of -7 is 7. So this would be 2 times 7 plus 3. Is that equal to 17? And 2 times 7 is 14. Plus 3 is definitely equal to 17. So x equals -8 is indeed a solution to the original equation. Now let's take a look at a few more practice problems. Let's solve the equation 2 times the absolute value of the quantity 4x minus 2 plus 4 is equal to 12. Our first step is to isolate the absolute value. So we need to subtract 4 to both sides. This would leave us with 2 times the absolute value of the quantity 4x minus 2 is equal to 8. And finally, to isolate the absolute value, we need to divide both sides by 2. This would leave us with the absolute value of the quantity 4x minus 2 is equal to 4. Let's check the value of c. C is 4, which is positive. That tells us that this equation is going to have 2 solutions. So we set the algebraic expression 4x minus 2 equal to 4 and the algebraic expression 4x minus 2 equal to -4. Now let's go ahead and solve the resulting equations. Looking at the first one, 4x minus 2 equals 4. We want to get x by itself, so we need to add 2 to both sides. This would leave us with 4x equals 6. Dividing both sides by 4, we would get x equals 6/4, which would reduce to x equals 3/2. Now let's go ahead and solve the second equation, 4x minus 2 equals -4. Once again, we would add 2 to both sides. That would leave us with 4x equals -2. Dividing both sides by 4, we get x equals -1/2 after we reduce our answer. I'll leave it to you to check, but x equals 3/2 and x equals -1/2 are in fact the solutions to this equation. Now let's solve the equation 4 times the absolute value of the quantity 2x minus 3 plus 5 is equal to 1. The first thing we need to do is to get the absolute value by itself. So let's go ahead and subtract 5 to both sides. This would leave us with 4 times the absolute value of the quantity 2x minus 3 is equal to -4. Dividing both sides by 4, we get the absolute value of the quantity 2x minus 3 is equal to -1. Now let's go ahead and check the value of c. In this case, c is -1, which is negative or less than 0. That tells us that this equation has no solution. The absolute value of any quantity is never going to be equal to a negative number. Let's finish this video with learning how to solve absolute value equations graphically using Desmos. All of the graphs used in this video are linked in the video description below. Here are the directions on how to solve equation using Desmos. Enter the left and right sides of the equation as 2 separate functions, say f of x and g of x. Then click on the intersection point or points to reveal the coordinates. The solution to the equation is always the x-coordinate of the intersection point or points. Let's use technology to solve the following absolute value equations. Let's solve the equation 3 times the absolute value of the quantity negative 2x plus 1 minus 4 is equal to 11. To use Desmos to solve this equation, we're going to enter the left side of this equation as f of x and the right side of this equation as g of x. Let's go over to Desmos now. Once you navigate to the site desmos.com, you can either click on the graphing tool toward the bottom of the screen, or from the Math Tools menu at the top, select Graphing Calculator. Let's start by entering the left and right side as two separate equations. To enter the absolute value, you can either use your keyboard or the Desmos keyboard has an absolute value function built in. To make this graph a little bit easier to read, I'm going to increase the size of the lines. Currently, we can see the function f of x, which was the left side of my equation, but I don't see g of x on the screen. In order to see g of x, we're going to need to adjust the window. To adjust the window in Desmos, go over to the upper right-hand side and click the wrench, which is the graph settings button. Let's change the range of the x and y axis to be between negative 15 and 15. Now I can see both the f and g functions on the same window. To locate the intersection point, simply use your mouse to click on the intersection point. One of our intersection points is negative 2, 11, and the other intersection point is 3, 11. The solution to our equation is the x-coordinate of the intersection points. So that means that this equation has two solutions, x equals negative 2 and x equals 3. We found that the left and right sides of this equation have 2 points where they are equal. So the solution to our equation are x equals negative 2 and x equals 3. Now let's take a look at one last example. Let's solve the equation absolute value of the quantity x plus 2 is equal to the absolute value of the quantity 2x minus 3. To solve this equation using Desmos, we'll just let the left side of this equation be f of x and the right side of the equation be g of x. Let's go back over to Desmos and enter these two functions. Let's edit our functions f of x and g of x to match our current equation. F of x equals the absolute value of the quantity x plus 2, and g of x equals absolute value of the quantity 2x minus 3. To find the solution to our equation are the intersection points of these graphs, and it looks like they intersect at 2 points. Let's go ahead and click on those points. So our first intersection point is 0.33333. I would recognize this as 1/3. And our second intersection point is the 0.57. Remember, the solutions to the equation are the x-coordinates of the graph. So the second solution is x equals 5. If you're asked to express your answer as an exact value, you can use Desmos to convert this to a fraction. Click on the button to export this point to the expression list. So that entered the point into my list on the left-hand side. Below that, I'm simply going to type in the decimal 0.33333 repeating. And then just to the left of that, you'll see a little circle with a fraction bar. If you click on that, it will convert the x-coordinate of this point to a fraction, which it was in fact 1/3. We use Desmos to find that these two functions intersect at 2 points. That means that this equation has two solutions, x equals 1/3 and x equals 5. That's it for this video. Thanks for watching.